about user experience-driven architecture. So what are we building? We are building a mobile instructional platform. Okay, so what does that mean? As Joe kind of mentioned earlier, we were working with a client that a little over a year ago that really wanted to revolutionize the educational space, right? So think about like our traditional way that the classroom is working. The teacher will actually come to you with pen and paper. You take a test, they collect it, they go back home and they grade it, and it's just this long, laborious process. What our client really wanted to do was to actually revolutionize that whole process and make the classroom experience, ran by these Android tablets, right? So let's just take an example of like multiple choice. Okay, so let's just think about like this teacher going to the students and saying, all right, fill out this multiple choice, and you have X amount of time, and then they do it, pass out all the papers, pens, blah, blah, blah. And then they go and pick them up, and then they have to grade them later, everything I just talked about, right? So with something like this, what we could do and actually have created was something that we call quick poll. And what happens here is that the teacher can actually, ask a question, and all the students will actually have an option to answer this on the tablet, and then this teacher will actually get that in real time, get all the responses in real time, and they don't have to go and grade it. They even know which answer they want and all those types of things. So this is the type of platform that our client really wanted to get in the classroom and to, allow the teacher to actually conduct the classroom experience via these tablets.
Mm-hmm. So back to the whole point about trying to build a platform, right? So just to differentiate, this was not just one-off application that we were building that we would push through the Play Store and then that runs on all these students' tablets. We were actually building a platform. We were building the whole thing. So we were responsible for it end-to-end. We were responsible for it right from the hardware all the way to the third-party applications that you can see here that run on the tablet. So that's something that we were building.
So how did we get started with that? We ended up actually just focusing on all the individual apps. So we were given in the very beginning all these requirements of like the quick poll example or making a quiz or that type of stuff. So we actually were focused on all of these individual apps and making them work technically. What was really, really cool about this project was the user experience or user research that happened towards the beginning. So this was the type of thing that was very exciting for me personally, because on this project, usually the research happens afterwards and then they come back and say, oh, we didn't want that at all. Well, with this, we actually had people go out into the field and ask the teachers, what kind of content do they want? What kind of orchestration of the tablets do they want in their classroom? Videos, e-readers, what type of encyclopedia type of things that they want their students to have access to. So that was very important in this project. And we were pretty good at it, right? We're really good at making apps. We're really good at making Android apps and making sure they work. And the research was amazing. I mean, we actually got all this feedback and what the requirements were. So we were good to go on this, right?
Mm-hmm. But what about the platform, right? And what exactly is this platform? Frankly, when we started, as Cassie mentioned, we were focusing on these individual applications. We did not have a very good understanding of all these different components of this ecosystem. So we wanted to build something that was a container for all these different third-party applications. We wanted to make sure that the device was safe and secure to use in a school environment, because when we give these tablets to the students, there is a certain amount of trust and also legal understanding between us and the teachers that none of the applications that should not be accessed will be accessed via this tablet. We need to make sure that we build in something like a single sign-on functionality so that we do not ask for the user information over and over again. And also, it gives us an opportunity to tailor the content that's on the tablet to that specific user. So if you're a 6th grade student, then you should be getting apps that are related to 6th grade and not something that's not related to you. And also, given that we were going to be deploying these applications, these tablets in different schools, we needed a way to remotely manage these these tablets, because it was going to be very hard for somebody to manually go and fix all these different tablets if something went wrong. So we wanted a way to kind of sit back in Development Center and look at what is the status of these different applications. Or for that matter, even the customer support people would need to know which tablets are functioning properly and which are not. So that was basically all the responsibilities of the platform.
So how did we go about doing this? We were thinking, as a developer, we look at those problems, and as developers, we said, all right, let's go to the technical architecture and let's solve these issues, right? So how do we go about doing that? We ended up actually embedding the tablet with a remote agent. And so, for example, when the student opens up their tablet and turns it on for the first time, this remote agent will actually send a status to the server. And the server will say, okay, the tablets are ready to accept all of these apps and contents and download all of them from our server so they can have, like, whoever it is, the sixth grader needs, encyclopedia and these particular books and all those videos. And so what happens here is that they're going to be pulling all of these apps and contents down to the tablet itself. So this solution sounded great to us. We were saying, okay, remote agent, go to the server. Now bring down all of our apps. Bada bing, bada boom, we're done, right?
But what about the user experience, right? Frankly, we did get the solution to work. Don't get me wrong. We had a pretty good solution. It's just that all these different components in the system didn't quite work very well with each other. And that was partly because we did not understand the ecosystem well enough as we should have, right? There are multiple parties at play here. There's the Android operating system. There is the remote agent that we talked about. And there are all these different applications which would ask you for all different kinds of permissions to click on. And that led to way too many clicks to get you started. So each application, if you've downloaded an application from the Play Store, you would see all these different pop-ups coming up saying, do you agree to provide this permission? Do you agree to this? And all those different things meant that there were way too many clicks going on. The other thing was we had inconsistent UI. So if you've seen the Android screen, it's typically dark, it's black, and our applications had a white background. So there was this inconsistent UI, and frankly, it was not the best user experience that we were showing to the user. And they were, frankly confused as to what is really going on. There was no good handle on what is exactly happening in the background. The other problem that we had was this problem of fidgety user, right? So if you let the tablet do its thing, you would be okay, but we know that never happens in a school, right? So students are going to click on all kinds of buttons and anything that you can find. So we were getting into all these kind of weird scenarios because somebody just hit back button. Somebody just hit the home button when they weren't supposed to. So we were getting into all those kind of corner cases. And frankly, that was making the testing a lot more expensive. And we really weren't catching all these different things. So one of the things that you have to understand is when you typically build a web application, you build everything yourself, right from the navigation. So you can direct that flow very well. But when you're working with a system like Android that already provides you a whole bunch of things, most of your work is actually undoing a lot of that work. You don't want students to go to the settings. You don't want them to hit back button when you don't want them to hit back button. So there was a lot of those edge cases that were happening. And the other thing was the remote diagnosis. As we said, that yes, all these things were happening, but there was no real sense of what was happening on these tablets remotely. So there was no good way to tell that X number of tablets had this problem and Y had this, so you can do this. So there was no communication between the server and the remote agent. And I think this slide really epitomizes the problems that we had. So at one point in the workflow, we had the screen which said, please click the home button. it was a bit funny. But we had to do that, and the technical reason we had to do that was because hitting the home button resets the state of the application, and then it makes it go in a certain flow. But that's all nonsense when you think of from a user's standpoint, right? It creates all kinds of problems. First, it's not a hands-off process for the user, right? If we could build something that even if it took half an hour, but if it did everything by itself, that would be okay with no user interaction, right? Because the teacher could then say, just keep all those tablets aside. They're doing what they have to do. We're going to concentrate on this class thing. And they can do that. But that was not an option because at some point you had to hit the home button. And how do you know when to hit the home button? You cannot give those instructions in advance. The other thing is, what if they hit home button before they were actually supposed to hit home button? And that would create all kinds of problems. So you had to hit the home button at the right point. So anyway, so I think what we are trying to point at is even though we had a good solution technically, the user experience wasn't quite there when we started off.
Yeah. So yeah, I mean, as Praful was mentioning, the technically speaking, we understood what we wanted to do, but the user experience, the platform user experience is not UI experience, right? It's not like a website that you say, okay, we're going to go through this flow, and this is the UI, and this is what's good for the user, right? It's not visual. We're trying to pull down all these different applications in the background, and the students, the teachers, the users don't really know what's going on. And this is something that we actually had to embrace with the platform UX, is that it's a very deep technical understanding, right? There's all these dependencies with these different apps. And again, what Praful is saying, you need to press the home button to reset the state. How is the user supposed to know that? That type of stuff. So.
And this is what I was talking about, that when we started off, this is how things look like. So this is, let's say, our efforts of user experience, and these were the efforts of architecture, the hardcore technical development architecture, right? And that's the world that I normally come from, where user experience is associated with making things look pretty. And I know that's not standard on all the projects, but typically that's what happens, is the user experience folks design the front end and the wireframes and all of that stuff, but they never really have to think about the architecture per se, like what database are you using and those kind of things. But here on this project, we saw that these two things were converging, and they were coming together very, very closely. So that's the reason why we are here. And now we're going to talk about some of the most important lessons that we have taken away from this experience.
So using the device. Okay, so this is a very standard, let's log in on a web app. Like we log in with our email and our password. And once we log in, we're ready to go, right? But on the tablet and on this actual platform itself, imagine 30 students sitting in a classroom and you're saying, hey, type in your email and type in your password. Oh, and by the way, put in the Wi-Fi name and Wi-Fi password. That's disastrous. Like no one's going to get that right, especially 30 kids, right? And so the solution that we came up with here was a QR code scanner. This was actually a really good solution that took a lot of time and thought into how we're going to approach this situation. So this worked in a way where the students will actually open up their tablet. They are given their own QR code. They don't actually know their password. They don't know the Wi-Fi. They don't know the Wi-Fi password, thank God. And all they do is they use the Android camera, and the scanner scans, and it actually logs the student into the tablet, and now we have our single sign-on. The benefits to this really were, first of all, like the problem I explained earlier, the students, will get that wrong. So it could be very error-prone if you don't have something like this. The second thing is actually security, right? Like each school has their own Wi-Fi. Each school has their own Wi-Fi password. We don't want the students actually knowing all that information. So that QR code scanner was very important to just let them sign on, boom. The third thing was actually kind of important was disabilities, right? Like it's actually very hard for a kid with a disability to be able to sign in manually, and this is actually a very easy, seamless way for them to just actually sign on with their tablet. So that was our solution for actually using that device.
And just one quick note on that. I mean, the QR code scanner wasn't just straightforward. Oh yeah, you put a QR code scanner and put it on the tablet, right? It did make the architecture complicated because now you have to, first of all, think about another application in your ecosystem. You have to maintain it. And second, you are dependent on the camera. So what if the camera doesn't work, right? You have to think about a fallback for making sure that it works. And all those kind of things that you have to think about when you come up with a solution like this. So the other thing that we talked about was guiding the user, right? And this is, we're talking about the tablet user at this point, the users that are actually going to use the device, right? And as I mentioned before, that a lot of time is actually spent in making sure that the user can get to where they want to get to easily and not get at all where they shouldn't be, right? And this meant that we had to set up the navigation. And one of, so that was the requirement that we had, and one of the technical fallout of that was being able to set the home launcher. So I don't know how many in the room are Android developers, but Android does not normally provide you a way of setting the home launcher. And what I mean by the home launcher is when you hit the home button, what you usually see is that screen where you have all these different applications. We wanted to change that because when you are installing all these different applications, we do not want you to go anywhere. We want you to sit on this screen which just had a spinner on it and says, please wait while we download stuff. So you don't want somebody just hitting the home button and just going to altogether different application or whatever. Maybe that's in the middle of a download. So you had to basically cut down all these different routes in which the user can go and block it. So another example would be disabling the back button. So things like that. The next thing we had to do was secure the device. As we mentioned, it's a school environment. We have to make sure that the tablet is safe. And for that, we had to think about how we can block different applications that are running on the tablet. So there is no straightforward way in Android to block an application. So we had to come up with our own custom utility that would block these unwanted applications on the tablet. Don't bother the user. So there are times when we do not want the user to worry about all these technical things. Especially, they shouldn't be seeing the screens that they do not care about, like especially the permissions screen. So all these applications are actually bought by the school or the district. The user does not really have a say in whether they want the application or whether they want to grant the permission or not. And to do that, we just had to silently install these applications, which means they get installed in the background and nobody has to know about it, right? And that is not something that is provided by Android out of the box. Again, that is something that we had to build on top of Android. So now we're going to look at the Android architecture or the tablet architecture. So this is what you typically work with when you are a Android app developer, right? This is your hardware, and the Android OS talks to the hardware, and then you have your third-party applications that basically talk to the Android OS. So let's say you write your own chat application, so that's going to do that. So the assumption is that in that case, you will be accessing only the public-facing APIs that Android provides. There are a lot of those, so you can make good use of that. But the situation that we had, the problems that we had to solve, like we were talking about on the last screen, which is setting the default launcher, silent install, all of those, we would not be able to do those with using these standard APIs. So what we did was come up with this remote agent, which we talked about, which was a separate Android application that would sit on the tablet and then talk to these custom wrappers. So these are the wrappers that we built around the Android OS, and they would allow us the ability to do things like silent install and setting the default launcher. And going a step forward, we added additional utilities to Android. So these are the ones where you have like blocking different applications and whatnot. So all I'm trying to say is this was not easy at all. we had to look at the Android code itself, and I'll show you an example of what we mean by this. We had to look at the code, understand how it works, and then because we had a very close integration with the vendor, we could go back to them and say, hey, we want you to make these changes to the Android operating system. And by the way, can you also put this application in Android itself so that we can use it? And then they would package it, they would compile it, and they would put it on the tablet. And then our remote agent would use all those different APIs that were on the tablet. So I'm going to show you a quick example of what I mean by these non-public APIs. So if you look at Android code, and grep code is a way you can look at the Android code, there is this API which is available, which is called install package. So this is a way you can install applications on a tablet. And if you use Android quite regularly, you would know that there is a way you can plug your Android into your laptop, and then you can, if you have the USB debugging turned on, which is like enabling the developer options on the tablet, you could do some of these things via that. But it means that you need access to the developer options, and you need to be in the proximity of the device, right? Because only then you can plug it into your laptop and make it do things. But we wanted to do all of this remotely. So there is no way to do this remotely by the remote agent. So then this is the package manager public API, and if you search for install package, there's nothing in there. So that's what I mean by looking at the code, telling the vendor that, hey, we want you to expose that API, building wrappers on top of that, and then accessing those via the remote agent to do what we want to do. And that was the second learning that we had. For guiding the user, you have to make all these kind of Android customizations on the tablet.
Yeah, so Praful was talking about the tablet user, but now let's talk about the actual administrative user. So informing the admin user about what's going on with all these tablets. So what we did allow the admin to do was these set of operations, okay? So the admin user actually has control over all of these tablets, and they can actually send messages to these tablets and make sure that they're online, like saying, oh, hey, I'm here, I'm online, are you available? Installing apps was a big thing because the administrator, if a student actually didn't have an app, or they switch class or switch section or something like that, the admin can actually say, oh, let's actually add a specific app to this class or a specific app to this student. So they had the rights to install the app from this interface that we built. Another thing is actually blocking the settings. So as Praful mentioned earlier about those developer settings where you can plug in your USB and install different apps and those types of things, the administrator was able to block those types of things. Even when you go on the tablet right now, you can actually go to apps and uninstall them manually, right? So this allowed the admin user to say, okay, students can't even touch that. They can't uninstall anything. They can't open up the developer options, et cetera, et cetera. This was also good because they could unblock these settings if we needed to debug it at some point. If something went wrong, if we needed to look at the different apps and different settings, then they could actually manually go in and do that. So this is sort of the kind of view that the admin could have. So these are the serial devices of all the tablets. So each tablet has their own serial number, and we have a status for each of them. So we have something like the student or the tablet is compliant, right? So it's communicating well. If I want to install an app on that particular tablet, then I can do that because now that tablet is compliant with my admin. We also have non-compliant. So this is something where it's actually not communicating well. I'm not able to communicate appropriately with them, and so we have to actually go and see what's going on with that tablet. Why isn't it compliant? Which serial number this is, and we actually have information about what school this is at, what student it is, and so we can actually go and look at that tablet. For those really sneaky students who want to root their tablet, we actually can tell if they did that as well. So if we see that they've rooted it, then we can actually go to that student and be like, all right, give me your tablet. What did you do? And then, of course, we have the unknown state. If there's some sort of weird communication, if we haven't talked to the tablet in quite a few minutes or weeks or something like that, then it's unknown, and let's go check that tablet out. Has it been turned off for a very long time? That type of stuff.
So that's great, right? If you can get to that point, I think it's great. But one of the things that we have found out that it's extremely hard to get an accurate sense of what state a device is in, and that's because of some of the that's because just the fact that these tablets are remote, and there are multiple things that could go wrong. So I'm going to talk about the server architecture that we have come up with, just to make sure that we can communicate these tablets on a regular basis, and we can send the operations that we want to send them. So this is how it works. So when an admin expresses a desire to make change to the state of the tablet, we send a notification to GCM. So for folks who don't know, GCM is Google's cloud messaging. What it offers you is an ability to notify a tablet. And the reason why we had to use GCM is because we have Android on the tablets, and that plugs in really well with that. And also, it's a pretty hard problem to solve, where you need to have something running on the device all the time, so that when the GCM pings it, it should be able to wake up and respond quickly. So, and Google has already solved that problem, so we said, well, let's use that. So when we need to notify a tablet, we would message GCM and say, hey, can you tell this tablet that I want it to do something? So then GCM sends that notification. It wakes up, informs our agent that is running on the tablet, and then it comes to get its operations. It says, hey, server, looks like you have something new for me. What do you have? And then it asks for its operations. And then we send it back different operations. These operations are nothing but it's a JSON payload that we send to the tablet, and the tablet, the remote agent on the tablet knows how to interpret those messages. And then it goes along and processes all these different messages, like showing a message to the user, installing a certain app, blocking settings, and whatnot. And then when it's done, it reports back the status to the server. So this is the flow that typically happens when you do something as simple as send a message to a tablet, right? So this is what we have. And this is all good in a happy world, right? In a happy world, everything works fine. But what happens in a not-so-happy world, right? What if we were never able to inform the GCM? What if GCM servers were down? What if the tablet was not receiving the GCM messages? Then what do we do? So in all of this, we have to plan for contingency. We have to do some contingency planning. And as part of that, we were doing retries on the server. So we built a pretty sophisticated system retry mechanism here, which would wake up at a certain time and then notify all these different tablets that needed notification, be it whether because they just received an operation, whether they haven't been responding for a long time, all those cases. What happens if the tablet is not able to communicate with the server? What if the server was never able to send the operations because the server was down? So what I'm trying to show is there are many links in this diagram that could possibly break, and we need to factor all of those when we design when we design our architecture. And to fix that problem, we had a retry on the server. And the worst case, what if the tablet was never there? What if the tablet was the battery was down, or something like that? And we have to think about all these different corner cases just to make sure that we can provide the admin user with a reliable and an accurate compliance mechanism. Because it's very easy to lose trust of the admin when you show something as compliant, but something is actually not compliant. So to provide a good user experience to the admin user, you have to have a very robust architecture.
And also, just to add to that, I mean, these admins are actually managing many, many, many different tablets. So this is at a large scale. So if we have a good way of actually communicating with all these different tablets, then this is why we need such a robust system for it.
And this is the JSON that I was talking about. So as you can see, this is a simple JSON where you have a send message operation, and then you pass in the message. So that's pretty simple. One of the things that we did, and this is a type of an operation, a lock device operation. So what this lets the admin user do is, let's say somebody calls up and says, hey, this tablet is stolen. The first thing they can do is lock that device, right? Or maybe just some kid loses his tablet, then that's what you want to do. And we did that, but we got into this situation often where the tablet used to be out of communication with the server. So it used to be locked and out of communication. It's essentially the tablet has been bricked, which is you cannot do anything with it. So one of the things that we did was introduce this fallback mechanism is when you are locking a tablet, you basically set the password at that time on that tablet, and then you show this password to the admin user. So if somebody finds the tablet, and if it cannot communicate back to the server, all they have to do is make a phone call to the support center and say, hey, what's the password for this tablet? And then they can punch in the password and they can open it. And they can at least do something with it from that point on. So we have to build this fallback mechanism into our operations. And that brings us to the third learning, which is in order to inform the admin user, we had to build this robust compliance mechanism. And really that brings us to the end of the presentation where when we started off, we were operating in this zone where user experience did their thing and the architects or the developers did their thing, and there was just a handoff between those, like, hey, I want you to build this, the developers go build it. But what we realized in the end that each and everything that we did affected the user in a very substantial way. So we had to think about anything that we did, how does this affect the user? And for that, we had to think about this entire ecosystem that the user is operating in and design the architecture to make the user experience as friendly as possible.
Yeah, and as a developer, like being on this project, it was very interesting to be able to actually go to the schools and actually see the users use it. And it's good to be in that mindset as a developer, because as Praful said, we're kind of in our own world. We just technically come up with a solution and not realize what the users are dealing with. So being on this project was very interesting to get to experience both sides. Mm-hmm. So that's it.
That's it. Thank you.
Yay.